Good morning, class. We have finished another chapter in our GoMath book, chapter 4. So now it is time to go over our study guide so that we are prepared to take our chapter 4 math test. So yesterday you should have finished all 3 pages front and back of your study guide from your math textbook. So go ahead and grab those pages and follow along with me to make any corrections or add anything onto yours that you may have forgotten. Okay? Number 1. Mrs. Ruiz sorted spools of thread into 4 boxes. Each box holds 5 spools. How many spools of thread does Mrs. Ruiz have? Okay, draw circles to model the problem, then solve. You can see they've already started your picture for you. Here are your 4 boxes. 1, 2, 3, 4. So she has 4 boxes. How many spools went in each box? 5. So I'm going to draw the 5 spools in each box. Okay. Got 5 spools in each box. Okay. So what would be your multiplication sentence? Well, you have 4 groups of 5, right? And although we've already mastered our 4s, we should have our 4s memorized. If you have forgotten it, you can easily count by 5s by saying 5, 10, 15, 20. Okay, so 20 what? Go back to your question. How many spools of thread? 20 spools of thread. Number 2. For numbers 2a through 2d, select true or false for each multiplication sentence. Now, should I look at these and just guess whether it's true or false? Absolutely not. I need to solve each multiplication problem and see if that's the correct answer. 2 times 8, well, any number times 2 is that number doubled. 8 plus 8 is 16, so 2 times 8 equals 16 is true. 5 times 8 equals 40. 5, 10, 15, 20, 25, 30, 35, 40. Yes, that is true. 6 times 8 equals 56. We haven't memorized our 6's yet, but we have memorized our 3's and our 4's. So I could say, well, half of 6 is 3. So 3 times 8, and we've memorized our 3 times 8, so that's 24. And then because 3 doubled equals 6, we'll double the answer. This is distributive property. And I get 48. 6 times 8 equals 48. Not 56. False. Don't just guess on these. 8 times 8 equals 64. Well, I don't know my 8's yet. But I do know my 4's. So I'll write it down here. What's 4 times 8? Well, 4 times 8 is 32. Okay, double that because 4 doubled is 8. And I get 64. So this one is true. Okay. Bella is planning to write in a journal. Some pages will have 1 journal entry on them, and other pages will have 2 journal entries on them. If Bella wants to make 10 entries, how many different ways can she write them in her journal? Okay, so this question is going to require you to find all the different ways that she can fit these in her journal. Okay, and so there's going to be a lot of different choices for answers. And my suggestion to you would be to draw pictures. Okay? All right, so what you're going to do is, this is what you're going to be thinking about. Let me explain this. Some pages will have one entry on them. Okay, so 1 times blank. And other pages will have 2. And Bella wants to make 10. So we need to find all the different situations that would make this equation true. To go over this one more time in case you didn't see where I got these numbers, some pages will have one journal entry on them. Some pages will have 2 journal entries on them. And she only wants to do 10 entries. So we need to figure out how many one-page ones and how many pages with the 2 entries can she have. So there's going to be multiple different ways that you can come up with this, okay? All right, so we could do 2 times 5 would be 10, right? But she wants to do both of these, so then that would leave us no room for this kind. So let's go down. Let's do 4. So 2 times 4 would be 8, right? Okay, so if this equals 8, then that means you have 2 left to equal 10. Let me show you what I mean. So 1 times 2 is 2, plus 2 times 4 is 8, and it equals 10. So you want whatever this answer is, plus whatever this answer is, to equal 10. Okay? Let's try another one. So 1 times blank plus 2 times blank equals 10. Okay, we did 4. What if we did 3? 2 times 3 would be 6, right? What plus 6 equals 10? Well, 4. So we need this parentheses to equal 4. Any number times 1 equals that number. So put 4 here. So 1 times 4 plus 2 times 3 will equal 10. Okay, so we've got 1 way, 2 ways. Let's keep going and see if we can find more. All right, let's see if there's a third way. 1 times blank plus 2 times blank equals 10. So we did 4, we did 3. Let's do 2. Notice I'm starting with the bigger number because then it's easier to figure out how many's left to put in the little number. So 2 times 2 is going to be 4. What plus 4 equals 10? Well, 6. So 1 times blank equals 6. 6. So 1 times 6 is 6. 2 times 2 is 4. Add them together, you equal 10. All right, you think we can find a fourth way to put these together? Let's write it out one more time. Okay, we did 2. Let's do 1. So that means we have blank plus 2 times 1 is 2 equals 10. Well, up here we know 8 plus 2 equals 10. So if I put 8 here, so now 1 times 8 is 8. 2 times 1 is 2, and it totals 10. So here we found 4 different ways that she could arrange the photos. Okay? All right. There are 7 days in 1 week. How many days are there in 4 weeks? Okay, so we have 4 groups of 7. Correct? We've already memorized our 4s, so we should know this answer. But in the event that you have forgotten it, you can do 2 times 7, which is 14, and double it, which will total 28 days. All right, flip it over. Circle groups to show 3 times 2 times 3. All right. I want you to think of this as groups of. So I need 3 groups, and each of those groups has 2 rows of 3 in them. Okay? So 3 groups of 2 rows of 3. So here's 2 rows of 3. Okay, you see that? 2 rows of 3. Remember, we solve what's in parentheses first. So you're going to go circle what's in parentheses first. Then we do another 2 rows of 3 and another 2 rows of 3. So look, I have 1, 2, 3, 3 groups of 2 rows of 3. Number 6. Dale keeps all of his pairs of shoes in his closet. A pair. How many is in a pair, class? 2. Very good. So a pair is 2. Select the number of shoes that Dale could have in his closet. Mark all that apply. So Dale keeps all his pairs of shoes in his closet. The number of shoes he could have in his closet means it has to be a multiple of 2. So 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 3 and 7 are odd numbers. So nothing times 2 is going to make that odd number. Okay? Lisa completed the table to describe the product of a mystery one-digit factor and each number. Okay, this is our mystery factor right here. And we know that these products are even. And it says, give all the possible numbers that could be Lisa's mystery one-digit factor. Well, let's go back to the very beginning of chapter 4 and what we learned. Okay. How can we make this be an even number every single time? Up here we have odd, even, odd, even, odd. Well, okay. I know that an odd number times an odd number equals an odd number. So if I wanted to test my theory, 1 times 3 is 3, 3 times 3 is 9. These are odd numbers, all of them. But if I take an odd number, like 3, and multiply it by an even number, like 2, I get an even number. Again, if I take an odd number, like 5, multiply it times an even number, like 2, I still get an even number. So, even times even is going to be even, and even times odd is going to be even. The only way I'm going to get an odd product is if it's odd times odd. I don't have any odd products. So that means the mystery number has to be an even number. And I'm just going to write this down to remind you. It has to be an even number. And that means to be an even number, it's got to be 2, 4, 6, or 8. Could even be 10 or 12. These are even numbers. Okay? Any of these numbers could be the mystery factor. Oh, look at that. Mrs. Rankin almost messed up. The direction says one-digit factor. I hope you caught that. Let's scribble these out. This is why we read our directions carefully. Whoops. One digit. So your choices are 2, 4, 6, 8. Explain how you know that you have selected all of the correct possibilities. Well, because the products are all even. Okay? The products are all even, and I know, okay, I'm not going to write this in sentence format because I want you to see how easy this is. I know that even times even equals even. Even times odd equals even. But odd times odd equals odd. Okay? Even times even is even times odd is even, but odd times odd is odd. So I knew all the product, or all the mystery options had to be even. All right, let's go to the next page, 255. While you grab your page, I'm going to grab a drink of water. Doing a lot of talking over here. Okay. Kate drew 7 octagons. An octagon has 8 sides. How many sides did Kate draw? Well, she drew 7 groups, or 7 octagons, with 8 sides each. 7 times 8. Well, you don't know your 7s, and you don't know your 8s, but you know your 4s. So you can use distributive property to say 7 times 4 plus 7 times 4. Since we have memorized our 4s, you should remember that 7 times 4 is 28 plus 28. And we should not be adding that in our head. We should run off to the side and add it up. 2, 4, 5. And we know that 7 times 8 equals 56. So there's 56 sides. Jose buys 6 bags of flour. Each bag weighs 5 pounds. How many pounds of flour did Jose buy? So I have 6 groups of 5. Okay, well, I can skip count by 5 to get my answer. So I put up 6 fingers, 5, 10, 15, 20, 25, 30. 30 pounds. Number 10, break apart the array to show 8 times 6 equals 4 times 6 plus 4 times 6. So I have an array here that is 8 rows of 6, but they want it to be 4 rows of 6 plus 4 rows of 6. So I'm going to chop my rows into 4 and 4. So now I have 4 rows of 6 and 4 rows of 6, and that's the only thing they needed you to do. Circle the symbol that makes the multiplication sentence true. 9 times 6 blank, 3 times 9. Okay, well, what is 9 times 6? Well, use your 9s trick. Okay, 1, 2, 3, 4, 5, 6. Put your 6th finger down. You have 5 over here, so 50. 4 over here, 54. So I know 9 times 6 equals 54. Let's solve this side. 3 times 9. Now that's the associative property, right? Yes. So I could solve it this way if I wanted to. 3 times 9 and then add that up 3 times. Or I can move the parentheses because it's the associative property and it states that moving the parentheses will not change the product. And I know 3 times 3 is 9 times 9. Fingers, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have 8 tens, so 8 and 1. So 9 times 9 is 81. So this side equals 81. So now I'm ready to solve. 54 is greater than, less than, or equal to 81. Less than. You never, ever, ever want to look at these problems and try and guess. You need to solve for each side and then make a decision on how they're related to one another. Roberto wants to display his 18 sports cards in an album. Some pages hold 2 cards and others hold 3 cards. How many different ways can Roberto display his figures? Oh, here we go again. This is very similar to the problem on the first page. Okay? So let's write it out. We will have 2 times blank, we don't know how many of those, plus 3 times blank, and it's going to equal 18. Okay? I think the easiest thing to do is to start with the biggest number. All right, so 3 times what equals 18? 6. So what if we did less than that? So 3 times 5. If I did 3 times 5, that'd be 15, right? I'm going to try to squeeze all this in and work it out. If I did 3 times 5, it would be 15. 18 minus 15 is only 3. Can 2 times something equal 3? No, so I cannot use 5. All right, what about 4? If I did 3 times 4, that would be 12, right? And what plus 12 equals 18? Well, 4. So 2 times what equals 4? 2. Okay, so that's one way. All right, let's see if we can find another one. 2 times blank plus 3 times blank equals 18. Okay, so we did 4. Let's try 3. If I did 3 times 3, that would be 9, right? And what plus 18 equals 9? 9. Well, can 2 times anything equal 9? No, so we can't use 3. What about 2? 3 times 2 is 6. Okay, so what plus 6? Did you guys just notice the mistake that I made? Equals 18. Look at this. 4 plus 12 doesn't equal 18. 6 does. So this should be 3. My goodness. That's the second mistake I've made today. I hope you caught it and you were over there saying, that's not right, Mrs. Rankin. Everybody makes some mistakes. I caught it though. Okay, good. So back to this problem. So if I have 3 times 2, that equals 6. What plus 6 equals 18? 12. Well, 2 times what equals 12? 6. Okay. What else could we do? What else could we do? I don't even know if there's going to be another way. 2 times blank plus 3 times blank equals 18. So if I did 3 times 1, that's 3. But 15 plus 3 equals 18. So that doesn't work. You know what we could do? What if we did 3 times 6 is 18, so then 0 on those pages, and then 2 times 9 is 18, so then 0 on those pages. Okay, so we came up with 4 different ways that we can organize that album. Okay? This question to me is not my favorite because it feels like it's almost like a trick question. So if you were confused on that question, you're not alone. So it's okay. Number 13. A carpenter builds stools that have 3 legs each. How many legs does the carpenter use to build 5 stools? Use the array to explain how you know your answer is correct, okay? So the carpenter builds stools that have 3 legs each. How many legs did the carpenter use to build 5 stools? Well, this array shows me 5 rows of 5 rows of 5. So if I have 5 stools with 3 legs each, then I would have, there's 1 stool, 2 stools, 3 stools, 4 stools, and 5 stools. So I have 1, 2, 3, 4, 5 stools with 3 legs each. Okay? So that is 5 rows of 3, which equals 15 legs. Okay, and it wants you to explain your answer. So I would say that we circled 5 rows of 3. You also could have circled 3 rows of 5. Either way works. So I circled 5 rows of 3. And again, you could have circled 3 rows of 5, and it would have given you the same product. Okay, Etta buys some ribbon and cuts it into 7 pieces that are the same length. Each piece is 9 inches long. How long was the ribbon that Etta bought? So she bought some ribbon. Etta buys some ribbon and cuts it into 7 pieces that are the same length. Each piece is 9 inches long. Okay, so the original ribbon is going to be all these 7 pieces put together. So we need to find out this total. So I have 7 pieces of ribbon that are each 9 inches long. So if I do my 9s trick, 1, 2, 3, 4, 5, 6, 7, I put down my 7th finger. I have 6 on this side, so 60, and 3 on this side, 63. So 63 inches was the original size of the ribbon. Okay. Antone and 3 friends, we got to put those together, so technically it's 4 people, divide some pennies evenly among themselves. Each friend separates his pennies into 3 equal stacks with 5 pennies in each stack. Write a multiplication sentence that shows the total number of pennies. Okay. So we have 4 friends, right? So I've got 4 friends. Okay. So I have 4 friends times, what is each friend doing? Think about what each friend is doing. Each friend is stacking their pennies into 3 stacks of 5. Okay, if you were to draw a picture, you would have, I'll draw a star for each friend. There's the 4 friends, yes. And this friend did a stack of 3 times 5. And this friend did a stack of 3 times 5. And this friend did a stack of 3 times 5. And this friend did a stack of 3 times 5. So you have 4 friends, each did a stack of 3 times 5. Okay, so now we have to solve this. Well, 3 times 5 is 15 times 4. You don't know how to do that, but we can use the associative property and change the grouping. So instead we could say 4 times 3, oops, that should be times 5. 4 times 3 is 12 times 5. Okay, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So the 60 pennies shows the total number of pennies. Luke is making 4 first aid kits. He wants to put 3 large and 4 small bandages in each kit. How many bandages does he need for the kits? Okay, so let's draw a picture. We have 1, 2, 3, 4 first aid kits. Okay. Then let's draw 3 L's. These are our 3 large bandages in each kit. And 4 S's. These are our 4 small bandages in each kit. Sometimes I like to use the letters rather than just drawing circles or a picture because it helps you remember what you're doing. So now, how many Band-Aids are in each one? Well, each one has 7 Band-Aids, right? So we have 4 groups of 7. So 4 groups of 7, which we have learned our 7s, or not our 7s, sorry. We've learned our 4s, and we know that 4 times 7 is 28. So they're going to need 28 bandages. All right, number 17. This is just like the front page. We'll need to solve each of these equations to decide if this product is correct and then mark true or false. We're not just going to look at it at a glance, okay? So 3 times 7, we know our 3's. 3 times 7 equals 21. So this is true. 5 times 7, 5, 10, 15, 20, 25, 30, 35. False. 8 times 7, we don't know either of these factors yet, but we know 4 times 7 is 28, and we can double that number to find 8 times 7, which is 56. So 49 is false. 9 times 7 is 63. 1, 2, 3, 4, 5, 6, 7. Put your 7th finger down. You have 6 and 3, 63. So that is true. Circle the number that makes the multiplication sentence true. 10 times what equals 40? Well, that's an easy one. 10 times 4. For numbers 19a through 19d, select yes or no to indicate whether the sum or product is equal to 8 times 6. What is 8 times 6? I know 8 times 3 is 24. And so if you double this, you get 48. So we're looking for sum or product of 48. All right, what's 4 times 2? 8. So what's 8 plus 8? 16. No. 8 times 4, 32, plus 8 times 2. Let's add those up. 32 plus 16, 48. Yes. Okay, 6 times 4 is 24. 6 times 2, 12. 24 plus 12, 6, 36. So that's no. Okay, 4 plus 4 is 8. 6 times 8. Well, isn't that the commutative property of 8 times 6? It is. So 48 and yes. Chloe bought 4 movie tickets. Each ticket cost $6. What was the total cost of the movie tickets? So 4 groups of $6. We know our 4s. What is 4 times 6? 24. And normally I would tell you to remember the dollar sign, but they so kindly did it for you. Okay, let's look at number 21. Write a multiplication sentence using the following numbers and symbols. All right, well, here's what I'm going to tell you. The easiest way to start this is at the end. So you know that it's going to equal the largest number. So put your equal sign in 60. Now we just have to figure out how are we going to manage these to make them equal 60. Okay. Well, what's 5 times 2? 10 times 6. Oh, that's 60. So you could have 6 times 5 times 2. And because of the associative property, I know I could also have 6 times 5 times 2. And because of the commutative property, I know I can change the order entirely. And I could have 2 times 6 times 5. And I could put the parentheses anywhere I wanted. And I could continue that and do... So any combination that you came up with 6, 5, and 2, and using parentheses, is going to be correct. So as long as you follow my trick of putting the equal sign and the largest number down first, what remains will be your equation. All right, flip it over. We're almost done, kids. Okay, Lewis started a table showing a multiplication pattern. Complete the table, then describe a pattern you see in the products. So I can see that one factor is 3, and we're multiplying that times these factors. These boxes down here are our products. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6, 18, good, 3 times 7, 21, 3 times 8, 24, 3 times 9, 27, 3 times 10, 30. So what patterns do you see? Well, you could say that you're skip counting by 3 or that you're adding 3 on each time. Okay, so I could say I'm skip counting by 3. But I could also say that I add 3 to the product each time. If you multiplied 3 times 37, would the product be an even number or an odd number? Use the table to explain your reasoning. Okay, so 3 is odd. This is an odd number. 37 ends in 7, so this is also an odd number. Now let's go to our table. Let's look at all the cases where 3 was multiplied by an odd number. 3 times 1 equals an odd number. 3 times 3, odd. 3 times 5, odd. 3 times 7, odd. 3 times 9, odd. Okay. So if I multiply an odd number times an odd number, my answer would be an odd number. Now, I'm going to take you back to the reasoning we used earlier. I know even times even equals even. I know that even times odd equals even, and we know that odd times odd is the only way you get an odd product. Okay? And if you wanted to list the ones from above, you could say 3 times 1 equals 3, 3 times 3 equals 9, 3 times 5 equals 15, 3 times 7 equals 21, and 3 times 9 equals 27 if you wanted to show more proof from the table. Okay, look at number 23. Use the number line to show the product of 4 times 8. Remember, 4 times 8 is 4 jumps of 8. So I'm going to jump 4 times, and they should be 8 long. So because they're 8 long, I need to skip count by 8. So that means my first jump is going to land on 8. Okay? So this is jump number 1. Now I'm going to count 8 more. 1, 2, 3, 4, 5, 6, 7, 8. My second jump lands on 16. 1, 2, 3, 4, 5, 6, 7, 8. My third jump lands on 24. 1, 2, 3, 4, 5, 6, 7, 8. And my fourth jump lands on 32. So 4 jumps of 8, or 4 times 8, equals 32. If you did 8 jumps of 4, you did not represent the correct problem, because the problem you should have been represented was 4 times 8, which is 4 jumps of 8. I hope you made all necessary corrections to your study guide, and now you're actually going to head over to Think Central, and you are going to complete study guide number 2 tomorrow for your assignment.